Good morning, everybody. Today I'm going to talk about volcano plots, demystifying why and how. Firstly, what is volcano plot? It's a two-dimensional scatter plot with p-values on y-axis and metrics like relative risk, odds ratio, or hazards ratio on x-axis. Next, why is volcano plot? There are a lot of plots generally to display large volume of data, but volcano plot is very unique in that uh, because of the spatially constrained manner and also the metrics we use are different. Graphically, it presents measure of strength versus significance of a statistical signal, which is the p-value on y-axis. And also in large volume of data, it helps to easily identify the changes and can be used in exploratory analysis to emphasize important differences between the arms. Originally, it is popular in genomics microarray experiments. It helps to identify meaningful changes in thousands of genes as replicate data points to present large fold changes, and also helps in identifying the multiplicity adjustments and also in displaying appropriate estimates and adjusted p-values to reduce false positives. Estimates are nothing but the variables which we want to analyze statistically, and the false positives are type 1 and type 2 errors. Lately, the volcano plots are started in using in safety evaluations, mostly in adverse event profiles, and also in other areas like summarizing laboratory abnormality counts in defined time intervals, and also to find the outliers. The next one is on concomitant medications. In a trial where many medications, conmed medications are used, it might impact the treatment outcome. In that cases also, it helps to identify which medication is uh, mostly showing up with the p-value 0.05 less. How to build this volcano plot? What kind of data do we need? The overview of the data we are using to create this plot is adverse events data. This is just an example we are using to build the plot from a late stage trial with two treatment arms and the classified AEs using medical dictionary codes, dictionary ones. And the options we used are proc plot with statements like scatter, key legend, inset, text, and bubble. The input data we used here are system organ class, preferred term, risk difference, and p-values. How do we calculate the risk difference? Risk difference is nothing but it is calculated as the difference between the incidence proportion of an event in drug A and the incidence proportion of the same outcome in the drug B. P-values are calculated with respect to the derived risk difference. So this is the basic plot which we can construct just using the scatter statement, ref line, x-axis, and y-axis statements. On the x-axis, we see the risk difference, and on the y-axis, the log transformed p-value. And the horizontal dashed line is the 0.05 p-value, and these filled circles are nothing but preferred terms. And this is the code I used to generate that plot. I use scatter statement and the symbols, whether we want circle filled or any other colors or any kind of shapes, we can use under this symbol option. And ref line and statement is used to refer which axis I'm pointing to generate the dashed lines, whether it is at x-axis, y-axis at like 0.05 and 0, and y-axis and x-axis to plot the time points or intervals or the values. Next, I'm going to move on to the customized plot. This is the customized plot The basic plot is a good place to start with, but we have further provided options to generate enhanced plots to display all the information of interest, to specifically identify the AE terms with significant risk difference. So in this plot, we have displayed all AEs pertaining to an SOC in same color and labeled them. The dashed line on this y-axis is nothing but p-value at 0.05. So with points above the line having p-value, these are with less than 0.05, and below this dashed line is a p-values greater than 0.05. So the option I used here to generate this SOCs pertaining to a single color is, I'm grouping them. This is the option I use, and the data label just to display the labels of the preferred terms belongs to that particular SOC. And the next customized plot is this graph displays labels for AE terms with p-values below 0.05 only, and shows the favorability of an AE towards a drug. Data points with low p-values, which are highly significant, will appear towards the top of the plot, and those AEs are our point of interest at safety evaluation. So this part I applied a few formats, and also by applying the cutoff for p-value to display in the graph. I did some manipulation, a way to do the cutoff and all, and also the formats I applied, how to display which one is favorable to drug A and drug B. This is the code to generate the plot. The only difference from the previous customized plot is this text statement. This statement helps us to show the format, like favorability of drug A and B, and where should I position that. For that purpose, this text statement helps. So the rest is same as in customized plot 1. And also I changed the color to display it blue and the labels to the red. And next plot is this is another variation in Volcano plot, which is like a bubble plot where each bubble represents an adverse event. And bubble size indicates the total number of adverse events that occur in both treatments combined, and the radius of any bubble is proportional to the square root of the event frequency. The key variables I used for generating this plot is SOC, preferred term, risk difference, and p-value, and bubble size. So the first 4 variables are same as in scatter plot. Only the bubble size is the extra variable we require for generating the bubble plot. So this is the plot we generated. Bubbles to this right indicates higher risk for subjects in drug A, which is cellulite. And the bubbles to the left indicates a higher risk for subjects in drug B. So anemia is the most frequently occurring AE, which is like, it is favoring in drug B, but drug A is at risk for anemia. So how do we generate this plot? We'll move on to the code now. So this format I used for showing the favorability for, like which AE is favoring which drug, and to display the number of events with total population, we can use this macro variables to create, and we'll use this insert statement to display where to display this. And p-value less than, since I'm interested only in p-value less than 0.05, so I took the cutoff of p-value less than 0.05 here. And this is the code to generate the plot for bubble plot. The only difference is we need to use the bubble statement instead of scatter statement here. And also the size represents the size of the bubble and at what minimum radius it should start, the size of the bubble. I gave the options like B radius minimum and B radius maximum, up to what number we can display the maximum radius of the bubble. And this insert statement, earlier I created the macro variables uh, to display the number of events, A events with total number of population for drug A and B. So I use this insert statement to display in the plot and where to position that, whether we want it outside or inside the plot. So we have to specify the position of that. And also we can specify whether we need the borders to be displayed around that or not. And the text statement next is I used for displaying the favorability of the drugs by and also where to position those, uh, whether it's bottom or in the top. We can use this option position. And as we know, as we learned earlier about the x-axis and y-axis, what the numbers to display from where to start with, the intervals. And the y-axis is the p-value, which is the log transformed one. And the next statement I used is key legend, which refers to this statement bubble. This helps to display the SOCs, whether we want inside or outside the plot. So it's nothing but we are referring to this statement. We are naming it with A, and we are referring to that. So that's why we need to use key legend. And I positioned it inside, and the size of the labels, whatever SOCs I used, what size of the font I have to use, I gave this value attribute option with size equal to 8. That's how we create the bubble plot. With this, I'm concluding how to create the Volcano plot. In summary, where do we use this? We learned. So, and how to construct also we learned. So in summary, since safety is always a primary focus in drug development process, also the safety information will be voluminous and difficult to interpret, such as AEs. So always graphical representation is very beneficial. It helps to easily identify. And in such scenarios, Volcano plot is one such great tool to use to easily identify the differences in large voluminous data sets and display number of data points in spatially constrained manner. It runs only in one page. You can see which one are at risk. For example, in rainfall and dot plots, they run into many pages, so it's difficult to identify. But Volcano plot is different from those two, so it's very easy in a way to say to identify what we exactly want to look at it. So this paper we discussed the significance and interpretation of Volcano plot and how to construct that using the ST plot by providing an example from a late stage trial. So these are the references to refer to. Mostly this paper helps us to give information about the applications of Volcano plots in safety evaluation. And if we are interested to learn more about the false positives like type 1, type 2 errors, and multiplicity adjustments, this paper will help. And the last one is the code, how to generate this Volcano plot. Thank you.